Hello, this is Scott. Welcome back to my YouTube channel, where I cover data science and analytics topics, including demos of open source software such as R and Python, and then commercial platforms. Today I'm covering a commercial platform called Statistica, and we're going to be talking about clustering, non-supervised machine learning. This is actually the fourth in a series on clustering. So we have no designated target here. And this one is going to be real simple. This is one of the simpler techniques to do clustering. Let me pull up a data set. I'm actually going to pull up in the examples data sets, and this is one that we used previously on agglomerative clustering. And so this is the cars data set. So these are our car models, and we want to look at which cars tend to cluster together based upon these variables. So let me come up with a new, a new workspace, and I'm going to drop this data set in the workspace. And then I'm going to, with the feature finder, let me just type in cluster, and I'm going to use this two-way clustering, not the SVB, but just the two-way clustering. This, again, this will be short, very simple. Variables, I'm going to select all my variables here. And then, well, anyway, descriptive statistics for cases. So I'm pretty much using the defaults here. Let's just go ahead and run that, see what it looks like. The main output, actually, I do want to get summary statistics. So let me go back to quick results, and let me get some descriptive statistics. I'll just click everything and then run that. So I get some output. And one of the things that I get is this two-way, and the way to interpret this is that these are actually standard deviations from the norm. Standard. So we've rescaled. We have a distribution with mean 0 and standard deviation 1. So what I can see, actually, I want to find out, well, what I'm trying to do is, it's not showing every single model. So there is a way to rescale this if you just double click here, and then let me find it. Oh, skip values off. Click OK, and I thought that would do it. For some reason that didn't take. Off. Okay. All right. So there we got them there. All right. So every single car and every single variable in this two-way joining. And again, these are standard deviations. So what that means is this light yellow here is pretty much there's not really much distance between these cars for price. There is quite a bit of difference for the Porsche. So again, bright red is positive standard deviations, and then green is negative, the opposite direction standard deviations. And in fact, if we want to, this essentially is the table that we're replicating there. So that two-way joining results, if I were to compare it side by side with the actual values, we would see that eagle and braking would seem to be very negative. And then if I go to eagle and braking, you can see where that number is coming from, -4 standard deviations. So anyway, again, I wanted to keep this very short. This is sometimes useful for small data sets. It's not useful for clustering large data sets. Use the EM algorithm that we talked about previously, or the other cluster that you can find right here, right? K-means or EM algorithm, and those handle large data sets a lot better. Also, one advantage of this, though, is if you want to get a quick idea of the relationship between the variables and the individual cases, that is nice in that, let's suppose that you have patients as well as some variables on patients. It could be the individual patients that's driving the separation, or it could be the variable, the difference in the variables. So just something to consider. All right. So I will see you next time.